Yeah, we're going to stream a game a little bit later today. Okay, so I'm going to continue where we left off earlier today and start drawing more information about what animations are playing. So where we were was that we sort of had this stuff happening where we can draw the guy's mesh, and I can selectively turn those off via awkward key combinations. I can get various of these things. I'm probably going to want to edit the way those bind later, but for now the functionality is there, which is fine. So, you know, below the character here, let's go to where there's two characters so it's more obvious. Below the character is the name of the animation state in the state file, or the name of the node in the state file that we did earlier in development. So if you remember this thing, right? So these names are what it's drawing right now, which is good. That's going to help us debug a little bit. What it doesn't tell us is actually what animations are playing on the guy. So what I'm going to do now is draw that information. It's a little bit awkward, I think, because if you go to, remember that on the very first day of these animation streams, we did this thing where we map from a tag on the left to an asset name on the right. And these names can be pretty long, but these are what we see in the animations. And I think if we only draw the tags, if we provide that as extra data, it's not really enough information, because I think the animator probably wants to see this. So we're going to be drawing some pretty long strings, but that's fine. So I'm going to just start doing that. I'm going to go back to our HUD file. We have a font. I'm going to have a small font, and we're going to initialize that at the same time. And I'm just going to try out the small font to make sure it works. Draw animation info is not very... Yeah, okay, it's fine. It draws a lot of things. So here we do the 2D rendering, and we do all this stuff. You know, this is figuring out where to draw the text, and then we draw the text. So I'm going to do the following. I don't remember. For fonts, okay, we have this default line spacing. So what I can do is I'm just going to say, you know, font.default line spacing to go down to one line under that animation name. And I'm just going to draw a hello sailor pretty fast. And I'm going to do, we're going to pick different foreground and background colors. like a kind of a bluish. I don't know. I don't know what's a good color. We'll theme the colors later. And I'm not going to worry about the x coordinate. Well, I'm going to reset it back to what it was. And I'm going to recompute the offset because we're going to use the small font. Like so. Oh, and I said name down here, not text. I don't know why it's really so far down. I would say that's a little too small, honestly. And the color's super ugly. Let's swap the green and blue. And, oh, right, okay. So actually my Y, let me get a different window up. So the Y, when you say draw text at a certain Y, that Y is the baseline of this text, and this has not really any descenders. So we actually want to go down by small font default line spacing, maybe with a little bit extra, but okay, there we go. Still way too small, but it's drawing in an approximate place for how big it is. So now what are we going to do? We're going to have multiple lines of text. When I say lines, is dot dot string lines dot allocator equals temp. Do I have? Yeah, I have temp. And then I'm just going to add a bunch of lines. I'm going to say add lines hello sailor. I'm going to say there are 69, 105 leaves in the pile. T and AT at the same time. Okay, so we've got 4 lines of stuff, and I'm going to go 4 lines. We'll say, call it text, and this doesn't need to be in the loop, and neither does this. And we're going to say this. After every line, we're going to say this. So now we're just going to draw a bunch of lines. Okay, it's still let's make it bigger. This is crazy. Small font. Wow, one is 0.3 and the other is 0.1. It just seems like such a much bigger difference. All right, this is probably too big. Let's say 1.6. Okay, that's, I don't know. All right. Now, I'm just going to offset this by some random fixed amount, first of all. I don't want to base it on the widths of the text because the texts that we draw are going to be changing every frame. Someone is saying, come to Brazil. I've been to Brazil. I've been to Florianopolis and Praia da Rosa, or however you say that. Yeah, okay, we'll make it a little bigger. So now let's just draw a backing behind all of this. We're going to draw a quad, and we're going to size it by the widest thing. So we're going to do a pre-process over the lines. That's why I'm putting them in an array. Draw the animation player state. So we're going to do this. And so the first thing is we're going to say highest width is 0, and we're going to say for lines, highest width is max, highest width, get string width in pixels, font it effects. All right, so now before we draw the background box, I'm going to say margin is divided by 2. We're going to say that's y1 minus lines.count times small font.default character spacing, and then minus an extra margin. Wait, x minus margin plus margin, and x1 equals x plus highest width plus margin. And we will say the following. BO 202020. Let's not use that function. Okay, immediate quad. We're going to do that. Maybe that'll show up on the screen. Or maybe we get a bunch of errors. Oh, because, right, the reason I had this in braces was because I'm redefining a bunch of variables that already exist. So let's put that back. This is probably going to migrate its way into its own procedure eventually. All right, what did I do? Undeclared identifier x0. Right. Default, it's line spacing, not character spacing. You dummy. Number mismatch float versus integer. Oh, geez. This is one of those things. All right, we're just going to... We're just going to do this, even though it's ugly. Later, I'm going to have a way of doing that better. All right, well, I didn't set the shader. So you see how there's some garbage down there below the actual text? That is the quad mapped to, yeah. we'll get this one. And then I think draw text will set us the shader text, but just in case. All right, well, we missed by a little bit, and our box is the wrong size. I don't know why. But, you know, you got to break some eggs sometime. You know what I'm saying? Okay, so first of all, it's the wrong size because, like I said, that Y that we start rendering at is the baseline, right? So what I'm going to do is I'm going to say box top. I'm going to save that value before I do that decrement. I'm going to say box top plus margin. Let's see how that goes. That should be worse. Got to declare box top, man. Well, Y1 is box top plus margin. Well, I'm going to have to play around. So fonts have different behavior with regard to how much they fill up their bounding boxes and stuff. So sometimes you just have to tweak this stuff for a specific font, which is annoying, but we may do that here. So let me figure, before I start getting tweaky about the Y offsets, like that looks, wait, Y1, oh, this has to be minus 2 times margin, because we're starting with Y1, which has a plus margin. So that'll be close enough for now. It's still not totally good. But that's because this font is weird about its bounding box. Why is the X coordinate so wrong? Why is the X coordinate so wrong? Or the width. Why is highest width so long? Oh, because I'm using the wrong font. I hope somebody caught that in the chat. I used the big font and not the small font. There we go. No, the error messages will not always be that crazy. So error messages, I kind of broke them working on some stuff, and I've been too lazy to fix them lately. So there are spurious error messages happening right now that have nothing to do with the actual errors, and I will fix those during the next live stream where we're actually working on the compiler. But right now we're working on the engine, so I'm leaving those even though they're annoying. Yeah, this keyboard that I'm using now is not the Leopold because it broke. This is a Razer Black Widow Tournament Edition 2014, which frankly, I don't think it's that great. I prefer the Leopold. What you gonna do? Almost done with my chocolate bar. Yeah, I don't know why it has to be so edgy. Oh, I forgot to use my tea water when it was heated up. Okay. So, let's bump all this down by some amount. Like before box top, let's just go an extra line there. Okay, that's, like this font has like a lot at the top. I don't know why. Like what characters ascend that high? Oh, wait. Right, the line spacing. I'm using the line spacing and not the character height. Let me try that. Yeah, okay, so what I want to use, it's a little bit tweaky, but I want to use 3 times the line spacing plus 1 times the character height. Okay. Yeah, okay, that's better. I was just a little confused. So now I want to shift this box to the left somewhat, but I don't want it to move around. So I don't want to pin it to the state name there or anything like that. Although maybe the state name should not be centered either, come to think of it. Here's what I'm going to do. Let's not center the state name. Let's put everything at the same X. So we're going to get rid of this because that's centering the text. Instead of centering it, then text X, we're going to offset by minus 0.5 in X, so it's about at the edge of the grid square. Yeah, see, there we go, there we go. And then I'll say, I want to draw this box behind everybody. Everybody, box top, where is that? So we need to know the lines and the highest width early. And we also need to say, well, here, include the state name in the rig computation. Highest width is max, highest width, and this, all right, and box top is going to be IY plus font dot character height, like that. All right. So we have y1 minus font dot character height like that. Welcome to UI programming. Probably broke something by doing this, and we say we don't have a BG color. Where'd it go? Let's see what happens. Well, that's a mess. What happened? I thought that was going to be okay. So down here, we want to draw this at title Y, title Y. I don't know why the box. All right, so that's, we just need the box now. Where's the box? What is X? Text X, that hasn't changed. Well, let's just print the numbers. Print x0, y0, x1, y1. x0, y0, x1, y1. x0, y0, x1, y1. Oh, I think it's just, we're probably in the wrong rendering mode. Yeah. So sometimes your matrix is set for screen coordinates, and sometimes it's set for unit coordinates. And that's what was happening there. So now we actually get useful. And instead of putting video game nostalgia in our lines, we say for player.channels, if it.animation array add lines it animation name. Hey. Okay, so it changes, it changes the number of lines because when we're blending animations, we draw more than one. So let's slow down time so you can see that happening. And what we're going to do is we're also going to draw the blend factors. So, we start in idle, then we go to move forward, which goes on the bottom, and then idle comes off the top, and then we go back into idle, right? So if I switch, this guy should start playing on the top. Let's go slow down even more. He should start playing active to inactive on top. Yeah. Right, so he's going to cross his arms. And now it's playing idle instead of idle to inactive, right? Because that's the loop. So this is pretty good. I guess I want to show the blend factor maybe, and maybe what time we are in the animation, although maybe that's not necessary. I don't know. Any questions about what the hell is going on? Does anyone have any questions about what the hell is going on, more specific than what the hell is going on? Does anyone have any answerable, actionable questions? Yeah. Okay, so now the question is, how do I want to draw the blend factor? The blend factor for the thing on the bottom is always 1. So I could draw these numbers to the left of the box. So maybe we do that rather than on the right, because if we put them on the right, then if there's some name that's really long, then it moves everybody's numbers over, which is annoying. So I think we draw them on the left. And I think I'll draw them without extending the shadow box first, and then we'll extend the little shadow box. I'm going to get rid of the word animation now. It's really not necessary. Is animation speed modulated by the player's velocity? Not really right now. So the blend factor I'm talking about is not the coefficient attaching a vertex to a bone. That would be crazy to draw that for every vertex. The blend factor I'm talking about is, when you start playing a walking animation, and then you want to go into idle, right? You don't just start playing idle. You start interpolating from walking to idle, and then walking has to eventually go away. So there's a factor by which you're blending between those animations, right? So it's that factor. It'll make sense when I do it. Does repeated user input go into a queue? Sort of. Yeah. What kind of blending are you doing? Well, every bone has a transform, so you figure out the bone's relative transform relative to its parent, right? And then you blend the position linearly, and use, I think, normalized lerp for the quaternions, and then the scales linearly, and then you can put those back into global space and turn them into a matrix. You don't want to interpolate matrices or anything. That's garbage. It's garbage. All right, well, let's get rid of this. How many lines of code we at? 56,267. All right. All right. We get rid of this as well. So let's look at the animation player. I believe the factors are on the... How do I figure out the blend factors? It's down here somewhere. Last blend factor. Channel node info. So I do some stuff. We have a blend out T. Yes. Okay. So channel dot blend factor for debug output is last blend factor. That shouldn't be serialized. Okay, so that's just going to be a number between 0 and 1 that we draw. And let's just draw that. So this is a little bit interesting. So we have this thing called lines. I'm going to make another thing called left lines because they extend to the left, so we're going to want to take the widths of them separately, or maybe that box is a fixed width. I don't know, man. So for player channel, if it.animation, array add to left lines, tprint, which is printing to temporary storage, percent format float, what was it called? Trailing width equals 3. That should compile approximately. Whoops. All right, undeclared identifier, because it's channel dot that. Oh, it's not channel dot, it's it dot, because the channel is called it. All right, so now we're not actually drawing those yet. Just making sure I didn't screw anything up. All right, so I'm going to have a highest left width for things growing out to the left. And oh, actually, never mind. I don't want to do that in parallel. I want to do this for left lines. All right. We're not going to include that. And then, when we draw the text, we're just going to say factor is left lines it index. That's a parallel array to ours. So we're taking whatever index we're iterating on, we pick the one from the other array. Have fun doing that in C++. And then you can do it. It's just laborious, and you have to do it all yourself in C++. And then let's call it factor text. Factor text. Factor color. Is going to be 0.85. It's going to be whiter. I don't know why. Maybe it shouldn't be. I don't know, man. We'll theme all the colors in a nice way later. So instead of ix plus ox, we're going to say ix minus margin, call it fx. Fx is ix minus margin minus factor width, factor factor width is like that, colon equals. I don't know, man. What are we even doing at this point? Margin is not declared because I declared it actually. Yeah. All right. Hey. So now we just got to extend the nicey nice box. Oh. Wait, what? My blend factor is inversed. Well, either I'm putting the inverse number or my animation player is broken, which is sometimes a good reason to visualize these things. Let's see. So last blend factor. Oh my God, it is backwards. Should be 1 minus this, right? So there's a timer that goes from 0 to the duration, and when the timer is 1, the blend should be 0. All right, well, whoa, that looks a lot worse though. No, that must be wrong. Yeah, that's, wait, what? Okay, no, okay, this is the factor, because of the order of the lerp, this is the factor going into, I'm drawing sort of the wrong, it's confusing. So this number that we're drawing is not like the strength of that animation, it's how much we blend that with the next guy. So when it's 1, it means it goes away completely because we've blended it with the next guy. Because it's easier to think about, I think I'm just going to draw 1 minus that, even though that's not strictly what is technically happening. So let's do that, and then let's make our box wider. So extend box leftward to include left extended numbers. X0 minus equals, what was it called? Highest left width plus margin. Left type float, right type int. All right, that's something. Oh God. Right, so drawing the 1 minus is not correct for the last animation. It's a little bit brain breaking. All right, it's goofy, but I could just change the order of the lerp. I don't know. This is confusing, but I would simplify it later if I'm going to mess with it. It's like 1 is kind of a special case anyway, because when it's 1, we don't lerp. We don't want to do any math to screw anything up. We just assign. So there we go. That almost looks like something. Well, I think that's it for now. I think the next thing I do is send an email to the animator and say, hey man, you could start using this stuff. And then he'll want a bunch of features that are not in yet, and then I can put those in on future streams. What do I think about IntelliSense? I think there are much better ways to do that. Will you be doing any IK in this game? Probably simple IK, yes. Like, if this guy is pushing something, we'll probably have an animation to get his hands in the right neighborhood, and then do some IK to put the hands on the object, for example. Or, you know, IK for people's heads to make them look in particular places. So that'll be a fun stream. All right, so for educational purposes, I'm going to keep the identities of people in the team or their email addresses private so that people don't spam them randomly. But I'm just going to do some team communication and let people know. And I'm going to say, well, it looks like I got motivated to implement the animation system and blasted through all the basic features. I'm pretty sure, well, I'm at the point where it would be most useful to try them out and then create some test cases for whichever specific features should be next. When you start the game, the animation debug info is shown by default. You can press F9 to toggle this display. Shift F9, what does Shift versus Control do? Shift F9 toggles the skeleton, and Control F9 toggles the mesh display. We can make different, or these bindings are specified in developer.keymap. Is that the name of the developer.keymap? Yes. Developer.keymap. But please don't edit this file as it is shared by everyone. Instead, you can make a new file called local.keymap of the same format and put whatever bindings you want in there. These are additive to developer.keymap, so you need to duplicate any. But keymap is not checked in because everyone is supposed to have their own, so you won't have one yet. Okay. If you want to change bindings, blah, blah, blah. I am not particularly convinced that the mesh or skeleton displays are very useful with the sizes that the characters currently are on the screen, so maybe we need a free cam or some kind of zoom mode. Not sure. In the box below each character is a readout, is a display of that character's current animation properties. It is pretty simple right now, but we can expand it as desired. The top line in blue is the node of the animation state machine we're currently in. Below that, in smaller text, is the list of all animations that are currently playing, along with the blend factor for each. The animator starts at the top of this list and blends in sequence. The animation at the bottom is always the freshest, most current one. As mentioned earlier, well, there are two kinds of text files you can use to control the animation state machine. The first has already been mentioned, the .animation names. Files such as warrior.animation names. The lines of this file look like this, with just the tag on the left, which is how the state machine file will refer to each animation asset, and the actual line on the right, which is changeable at whim, and each character has their mapping here. Anyway, the other file is human dot, what is it called? Dot animation graph. This is a list of all the states. This is a list of all the states. Well, this controls the state machine. It's pretty simple right now, but again, we can add features as necessary. The file looks like this, and so on. Whenever you see a colon, that starts a new node in the animation graph other nodes use this name when they want to designate where to go. Right now, each node has a primary animation that is always played when we are there. We discussed more sophisticated schemes wherein we wouldn't always be playing one animation, but it seemed good to start simple and then implement that when there's a test case. This primary animation is always indicated using the animation keyword, so the line says we are designating the primary animation for state active, and that animation is the one is the tag active, which for the warrior is mapped to this, with quotes. I think we're going to stream on my channel with the gaming stream. There are only 6 messages. They are the following. If in any state there is no message command, if in any node state there is no message command telling us where to go when we get one of these messages, then these messages will jump to their particular default states, and you'll get a log message that this happened. So the default states are state active, state walking, state pushing, pulling, dead. So these nodes need to be in the animation graph, but you are free to add new nodes arbitrarily. For example, says that if we get go state inactive, don't go to default state for that message, go to state API. Instead, the last command that's implemented so far is when done. Example. This says that when the animation for a particular state is about to complete, go to state inactive and run that animation. The O.2 at the end is timed in seconds before the animation is complete. When we fire up the new animation and start the crossfade. Isn't this exciting? It's a documentation stream. Yeah, documentation. Before the animation is complete, when we fire up the new animation and start the crossfade, if no number is specified, default is used. I don't remember what the default is. In our about times in frames, I guess animators like to measure time in frames, but it seems pretty weird to me since we might adjust the frame rates of the animations, which would then invalidate all the numbers in these files, and that seems pretty bad, but we can have the time units be whatever you want them to be. All these files are fully hot loadable, and hopefully nothing bad should happen if you edit them while the game is going, even if the edits are drastic. But of course, this is not heavily tested, so there are likely to be some problems. Let me know what they are and I will take them. So far, this is a pretty minimal feature set, but it's been fun, and it'll be interesting to expand it out. So let's come up with some test cases plus data of what needs to happen. There we go. That's my email that I'm going to send. Does the animator call go state whatever in the gameplay code? No, the animator doesn't touch the gameplay code right now. I mean, maybe that could happen eventually, but I don't think so. I think the gameplay code just sends these messages and the animator responds to them. I think the ETA for the game cast is going to be around 7 or shortly after 7, so in about half an hour. Is defining animation relationships like this permanent, or will you make it more efficient at the end when you know all the relationships? So it is probably permanent in the sense that they will always be stored in this data structure. But the data structure will probably be packed in memory more efficiently and won't be loaded from a text file, probably. Maybe it will be, because sometimes when you ship a game, if you have a small amount of data and it loads fast, you might as well load it from a text file. But if we were to care about efficiency, we would speed that up. What would happen if you hot load an animation while it's in the middle of playing it? Well, it's a good question. In theory, we should just continue on playing it. But there are things that can happen that we might not correctly be safetying against, like the number of bones changed, or the number of frames, and we'll see. If there's crashes involving that, we will deal with them. How does animation data come in? Just a bigger. I'll show you the animation data right now. It's really not a very special format. So the animation data looks like. It's not there. Where are the animation files? Really? Okay, here we go. It's really, so basically we say, here's the frame rate, here's how many bones there are, here's how many frames there are, right? And this is like just a transform that we apply to everybody. And the names of all the bones and what their parent is. And then for every keyframe, we list the transform for every bone in ASCII. So there we go. And then it keeps going until keyframe, there's 86 bones or whatever in every keyframe. So, it's not that efficient to parse all of this, but we don't care yet because we're not that animation heavy, but we will be animation heavy eventually. So we'll want to store this in a better format. But even so, a plain text format like this is vastly better than XML or JSON or some garbage like that. So, yeah, that's our current animation format. Oh, and so of each of these blocks, this is a position vector, right? That's a quaternion for orientation. And this is a scale shear. Wait. Yeah, this is a scale shear, which if you're not shearing is usually going to come out very simple. Right? So this is identity here, right? So it's 100, 010, 001, which is the 3x3 identity matrix. Quite possibly every single one of those lines in this file is like that. So you can imagine saying in the file, like, oh, we're not actually using that, so set them all to identity or something. And then you save half the data, right? Because this is 7 numbers and this is 9, so more than half the data is not even used in this file right now. This is exactly the same animation data format that we used in the witness. Exactly the same. These come from Maya actually, but yeah, it's a plugin that we wrote that just exports this format. All right, that has been the stream for now. I'm going to sign off and recuperate while we get ready for some gaming. So I'll see you guys all later. And I'm not sure when we're going to do more animation features. It might be soon. It depends, because like I said, there has to be a back and forth with the animator about what to do. So, see ya.